Okay, so for number 1, it says, in how many ways can a president, vice president, and secretary be randomly selected from a class of 25 students? So if you were doing just a permutation of 25, meaning like what are the outcomes, what are the different ways to set up 25 students? Remember, you would do what? 25 times 24 times 23 times 22 times 21, and you go all the way down to 1. However, we want to know only for 3 different ways, basically choosing a president, vice president, and secretary. So if we were to first choose the president, there would be 25 students to choose from. After you've chosen your president, how many are left then to choose from? Yep. 24 people to choose from for your vice president. Once you've chosen your vice president, how many people are left to choose for your secretary?
23.
Yeah, 23. So then you would have all the different ways. So if I were to take 25 times 24 times 23, what would your outcome be? Yep.
13,800.
13,800 different ways that you could choose randomly the president, vice president, and secretary out of 25 students. Okay? Let's go on to the next one. When it's set up like this, the second number is telling you how many you need, how many factors, and the first number is telling you what you're going to start with. So it's 5 times 4 times 3. Okay? So who can tell me what is 5 times 4 times 3? 60. So there's 60 different outcomes for this permutation of the first 3 factors of 5. The last one, it says, Adrian and Julian and 2 other friends will sit in a row at a baseball game. So let's stop right now. How many total friends are there? Yes? Yep.
4.
4 different friends. Good. Now, if each friend is equally likely to sit in any seat, what is the probability that Adrian will sit in the first seat and Julian will sit in the second seat? So do we care about the third and the fourth seat?
No.
No, it's just the first and the second. How many total people are there to choose from for the first seat? 4. Okay. Once you've chosen that first person, how many people are left to choose from for the second seat? 3. And we don't care about the third and the fourth seat, so we're not going to worry about those. So how many total outcomes are there possible for the first and the second seat?
12.
12. Good. So there's 12 outcomes. We want to know what's the probability of Adrian in the first seat and Julian in the second seat. We know if there's 12 outcomes, we got to find out how many different times Adrian can be in the first seat and Julian can be in the second seat. How many different ways can that occur? Yes, only one way. Because if Julian's in the first and if Adrian's in the first and Julian's in the second, that's the one way it can happen for us to, find that probability. So in the end, P equals 1/12.